So today we are going to learn about how to select and draw conclusions from samples. This is our chapter 11, section 4, page 766 to 769 from the textbook. So think about first the questions that come up to your mind sometimes. What are the methods for collecting samples? Or what is an unbiased sample? What is a biased sample? What is a margin of error? And what is that equal to? So our lesson target is I can identify different types of sample given a particular situation. I can calculate margin of error. I can find a sample size given a margin of error. So we are going to learn about a few different things over this lesson. First, let's start with the vocabulary. Population is a group of people or objects that you want information about. Sample is a subset of the population when it's too difficult, time-consuming, or expensive to survey everyone in a population. Sample types. There are 4 different sample types. Self-selected sample. It's members of a types who volunteered to be in the sample. Second type of sample, the systematic sample. Members of a population are selected by using a rule, example, every other person. Convenient sample, easy to reach members of a population. Random sample, each member of a population has an equal chance of being selected. So please write these 4 definitions in your notebook because they are very important to select and draw conclusions. Classifying samples. Let's do an example. A sports writer wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. Identify the type of sample described above. So the sports writer contacts only the coaches that he has cell phone numbers for in order to get quick responses. So in this case, the sports writer selected coaches that are easily accessible to him. So the sample is a convenience sample, and the convenience sample is always easy to reach. Members of a population are selected, such as those in the first row, as given in the definition. So read the question always so to define which sample is which. Another example. So a sports writer wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball and divide the type of sample. The sports writer mails out surveys to all the coaches and uses only the surveys that are returned. So part B is a self-selected sample because the coaches can choose whether or not to respond. So they choose to respond or not. Unbiased and biased samples. Unbiased sample is representative of the population you want information about. And most of the time, the chance for a random sample always to be unbiased. So random sample is always unbiased. And all other samples, the systematic and the self-selected and convenience sample, are biased. So a biased sample overrepresents or underrepresents part of the population. In order to draw accurate conclusions about population from sample, an unbiased sample should be selected. A biased sample, concert attendance. The manager of a concert hall wants to know how often people in the community attend concerts. So the manager asks 50 people standing in a line for a rock concert how many concerts per year they attend. tell whether the sample is biased or unbiased. Explain your reasoning. So the sample is biased because basically people standing in line for a rock concert are more likely to attend concerts than people in general. So it's a convenience sample and it's a biased sample. And this sample could be self-selected if they make phone calls for people to respond, or if they post a survey on Facebook for people to respond. So that would be self-selected sample. And this sample could be a systematic sample if the rule of selecting members of population that they use for selecting every other person. And the answer for this example is convenience sample, and it's biased sample. An unbiased sample. Let's do this senior class prom example. You are a member of the prom committee. You wanted to poll members of the senior class to find out where they wanted to hold the prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors to poll. Step number 1, make a list of all 324 seniors. Assign each senior a different integer from 1 to 324. Step 2, by using your calculator, generate 40 unique random integers from 1 to 324 using the randint feature of a graphing calculator. So the screen at the left shows 6 such random integers. If while generating the integers you obtain a duplicate, discard it and generate a new unique integer as a replacement. Step 3, choose the 40 students that correspond to the 40 integers you generated in step number 2. So please copy these steps down in your notebook. Let's move on. Another example, school website. A computer science teacher wants to know if students would like the morning announcements posted in the school's website. He surveys students in one of his computer science classes, identify the type of sample described, and tell whether the sample is biased or not. So the computer science teacher surveys students in one of his computer science classes where students are easy to reach. So the sample is a convenient sample because the sample is biased as the students of only the computer class are surveyed. So it is a convenient sample and biased based on the question. So please read the question carefully to decide which sample is which and if it's biased or unbiased. What if, in the senior class prom example, what is another method you could use to generate a random sample of 40 students? So place each student's name on a small piece of paper in a hat and draw 40 names. So this is a good way or another method you could use to generate a random sample of 40 students. Sample sizes. When conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. So as the sample size increases, the margin of error decreases. So the margin of error gives a limit on how much the responses of the sample would differ from the responses of the population. So margin of error formula is plus or minus 1 over square root of n. This means that if the percent of the sample responding a certain way is p, expressed as decimal, then the percent of the population that would respond the same way is likely to be p minus 1 over square root of n and p plus 1 over square root of n. Let's do an example. Media survey. In a survey of 1,011 people, 52% said that TV is their main source of news. So for part A, what is the margin of error for the survey by using the margin of error formula? So solution, use the margin of error formula, which is plus or minus 1 over square root of n. Substitute 1011 for n, so it's plus or minus 1 over square root of 1011. Use your calculator to find your answer, and you will get approximately plus or minus 0.031. So the margin of error for the survey is about plus or minus 3.1%. So multiply your answer by 100 to get your percent. B. Give an interval that is likely to contain the exact percent of all people who use TV as their main source of news. So to find the interval, subtract and add 3.1% to the percent of people surveyed who said TV is their main source of news, 52%. So 52% minus 3.1%, which is 48.9%. And 52% plus 3.1%, that is 55.1%. So it's likely that the exact percent of all people who use television as their main source of news is between 48.9% and 55.1%. I hope that helps to find the margin of error and to find the interval. Let's move to another example. A polling company conducts a poll for a US presidential election. How many people did the company survey if the margin of error is plus or minus 5%? So the margin of error is given, and we are looking to find n. How many people? So use the margin of error formula. Margin of error, write down the formula in your notebook. It's plus or minus 1 over square root of n. Then it's plus or minus 0.05, which is the margin of error, equal to 1 over square root of n. And you can cross multiply and solve for n. Or you can square both sides by using square roots. You can square both sides, and you get rid of the square root at the bottom, and you square the left side, and if you square the one, it stays 1, so you will end up with 0.0025 equal 1 over n, and that is equal to n equal 400 if you solve for n. So there were 400 people surveyed, and our answer, which is C, 400 people. Example number 3, the internet. In a survey of 1,202 people, 11% said that they use the internet or email more than 10 hours per week. What is the margin of error for the survey? How many people would need to be surveyed to reduce the margin of error to 2%? Please take a couple minutes to answer this question. So the solution would be margin of error. We need to write the margin of error formula down first, plus or minus 1 over square root of n. Substitute 1,202 for n, and use your calculator, so you get plus or minus 0.029. So the margin of error for the survey is about plus or minus 2.9% if we multiply by 100. So now for part B, you use the margin error again, write it down, and substitute plus or minus 0.05 for margin error. So 0.02 equal plus or minus 1 over square root of n, and you square both sides to get rid of the square root of n, and solve for n, you get 2,500. So 2,500 people need to be surveyed. We hit our targets. We identified different types of sample given a particular situation. We calculated the margin of error. We found a sample size given a margin of error. So your assessment is at page 769, problems 4, 6, 8, 10, 16, 18, 27. Thank you. Have a great day.